Today we are talking about vectors in 2 dimensions. It's going to be a little mathy today. I apologize, but all right. By the end of today, you'll be able to sketch vectors in 2 dimensions, be able to add and subtract vectors graphically in 2 dimensions, be able to calculate the resultant of vectors that lie on the axes, and calculate components of 2-dimensional vectors. You got a worksheet due tomorrow. We're going to be going outside tomorrow, so dress appropriately. Should be a good day tomorrow. Yep. All right. So, quick math review. Positive x-axis, negative x-axis, positive y-axis, negative y-axis, 0 degrees, 90 degrees, 180, 270, 360. Okay. First, second, third, fourth quadrant. Okay. We can also, in physics, use the compass rose, north, east, south, west. Never eat soggy waffles. Never eat sour worms. Whatever you want to say. Okay. All right. So let's say I have a vector that I want to sketch 40 meters a second at 30 degrees below the positive x-axis. In math class, they'd probably say at 330 degrees, but often you're going to see this like below the positive x-axis or below the horizon or something like that. So here's your positive x-axis. We're going to go 30 degrees below that. That looks about 30 degrees. All you need to do is estimate, draw. I'm not going to have you draw it to scale, just so that you know where roughly it is on the coordinate plane. Good with that? Do you remember last week when we were talking about subtraction and we made like a minus b, we'd make b negative, so we like plus a negative b. Okay. If I were to make this vector negative, how would I draw that? Should go 180 degrees in the opposite direction. Good with that? So anytime you make a vector negative, it just goes 180 degrees in the other way. Okay? Oh, wait a minute. We're not done there. All right, so another way you can be given a vector is, let's say it's 150 meters at 70 degrees west of north. To draw this, here's my recommendation. You read this backwards. Start north, and then go west, rotate west. How far? 70 degrees. (150 meters, 70 degrees. Good with that? If I said 150 meters at 70 degrees north of west. I would start at west, go north 70 degrees, and it would be over here. See the difference between those two? Right. So that's how you sketch vectors. Not too bad. All right, so let's say last week we reviewed adding vectors that are on the x-axis or along in one dimension. So we had 7 going to the left, 3 to the right. The resultant is 4 to the left. Okay. Today we're going to learn how to do 7 to the left, 4 up. Okay, when vectors are perpendicular to each other. How to find the resultant. So, one example, let's say we walk 500 meters south and then 1,300 meters west. What is the resultant or total displacement? So, the first thing we're going to do is we're going to sketch both of those vectors at the origin, or starting from the origin, and drawing away. It's got 500 meters south, 1,300 meters west. Okay. And then what we're going to do is something called head to tail. So on a vector, this is like the arrowhead. This would be the tail. What we're going to do is we're going to move one of those vectors, in this case the purple, from here to here. It was over here. Sometimes I like to refer to this as cutting and pasting. So I'm taking this and moving this. Notice I'm not changing the way it's pointing, nor am I changing the length of that, the magnitude. I'm just moving it so that the tail of this is at the head of that one. Good with that? And then, so that's head to tail. To find a resultant, I start at the origin and draw to the final head. And that is a picture of the resultant displacement. Okay? How would I find a numeric value for that resultant? How would I find the length this side? It's like a softball. It's like, Andrew, Pythagorean theorem. Okay? So I have 500 squared plus 1,300 squared is equal to c squared. Find that to be 1,393. That's 1,393. So, but a vector needs 2 things. I've got the magnitude. I'm missing the direction. How could I communicate direction? Southwest. That works, right? But isn't that southwest as well? So how could we be more detailed than southwest? North. Oh, man. Good thing I know trig. Yes. I could find the angle. Figure out. Okay, here's my recommendation. I would avoid using this if you possibly can. Two reasons. Number one, you rounded it. Number two, you might have made a mistake. If you can figure it out with the stuff that was given to you, that's more pure, if that makes sense. Okay? So you can figure out that angle. You feeling better?
Yeah.
Yeah. So what's your strategy?
I don't know.
Did we what do you say about making up the test tomorrow? Is that a because how you were gone all last week?
Yeah, except Monday.
We took the test Thursday, I think, right? So we took the test, right? Yeah, I think we took the test on Thursday. Because Wednesday you got that PSAT thing, so we're out. Like that's a kind of a trash day.
I mean, yeah, I guess I can do it tomorrow. But I didn't do the mastering or the review, so I don't know what to do about that.
Okay. Well, I mean, I guess we could do it Thursday.
Well, I mean, let me see.
Do you have a study hall?
Yeah, I have a virtual 10th year, so.
You are going to do that first.
What about this? After school on Wednesday? Oh, I got a better idea. I got a good idea. On Wednesday, after you get done with the BSAT, after lunch, it's just most kids are going to go home if they can drive.
Yeah, that works.
You want to do that? All right. I like it. All right. So what are we going to use? Sine, cosine, tangent? Tangent. So say tangent of nope. Tangent of theta is equal to opposite over adjacent, inverse tangent it. Find that to be 21 degrees. Thumbs up for good. 21 degrees. Now, if I said, hey, I want you to go 1,393 meters at 21 degrees, I would assume, I hope, that most of you would be like, okay. Shoot, not what I want. Miscommunication. So, what's one way I can communicate that correctly? Yeah, lots of options. Yep. At 21 degrees below negative x-axis. That was one way to say that. What's another way I could say that? Yes, yep. At 21 degrees south of west. It's another way I can say that. This is more of a math way. How you see this in math class. Somebody else. Oh, come on, math people. Step to the plate. What is it? What is this angle? What is that angle? There it is. Yeah. Okay. 0, 90, 180 plus 21. Any of those will work. You don't have to put all of them, just one of them. Okay. Good with that? All right. So, a follow-up question that usually comes up is like, oh, how'd you know you cut and paste the purple one? Like, what would happen if you cut and pasted the green one? Okay. Gonna work out okay. Okay. So, the only difference is you have a different triangle here. And so when you do tangent, it's going to be 1300 over 500, opposite over adjacent. And it's going to give you 69 degrees. So you could say 393 meters at 69 degrees to the left of negative y-axis is also a valid answer, or 69 degrees west of south. Good with that? Questions there? Here's a popular error. Find the resultant of these two. Okay. You'll find the magnitude correctly. This will be 1,393 meters. You'll get that part. But the direction, good luck. Okay. So always remember to do head to tail, cut and paste first. One safeguard, you always want the resultant to start at the origin and draw away from. Good with that? Talk to your neighbor.
Oh, what made me figure out this is when you sit for stretching.
Okay, correct answer is D, dangerous dinosaur. Okay. These two, you failed to do the cut and paste. This one, you went the wrong way. Start at the origin, draw away. Okay. Watch that. Talk to your neighbor. All right. Which one are you going to flip? The blue or the green? Green. So we're going to make that go up. And then it just becomes an addition problem. Correct answer is D, delicious donuts. Does that make sense how we did that? Okay. So this becomes a plus and negative. When we make that negative, we're going to flip that in 180 degrees. Okay. And then we just do head to tail from there. Get that? Okay. Talk to your neighbor.
I got the question right. I just didn't. You always. This is just better being on I can barely get
All right, what do you say? I heard some C's. Let's say we cut and paste B. Take the tail of this, move it to the head of this. Keep it parallel. The resultant. Let's say we cut and paste A. Keep it parallel, same length. Correct answer is C. Okay. Watch for that. Thumbs up when you have a guess. Talk to your neighbor.
Yeah, because I'm getting a lot of issues with like this. And then if you like add them, oh wait, no. Okay, so I'm gonna
Okay, which one are we flipping? B, we're flipping B. So B and negative B makes it go this way. Then we do head to tail. Correct answer is A. You get it? Okay. That was math. Let's do a little physics here. Thumbs up when you have a guess. Talk to your neighbor.
No way. I'm just. Oh. Oh, it's such a. I don't know how.
So I got yeah, like, it's really good. Everything.
Correct answer is okay. River's going downstream, 4 meters a second. You are swimming across the river at 3 meters a second. The resultant velocity, based upon how your friend sees you on the bank, is the resultant of both of those. 3, 4, 5 triangle. 5 meters a second. Going at that angle. What does that mean? Got a little demo for you. All right, so let's do this. This is my river. Okay, here's my river. Here's a swimmer or a duck. And you're going to see it go upstream. So it's trying to swim against the current. I'll do this a couple of different places. Swimming upstream. Upstream. You can't even see that. Upstream. 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 Okay. Now we're going to go downstream. Going downstream. Going downstream. There we go with that. Now we're going to go across the stream. Across the stream. Across the stream. That makes sense? 5 meters a second. going that way. Okay. All right. That's resultants. Components. So a component tells us how much of a vector is going purely in the x direction and how much is going purely in the y direction. Okay, how much of a vector is going purely in the x direction and how much of a vector is going purely in the y direction. So for example, so you have 120 meters, you walk 120 meters at 30 degrees east of south. Go ahead and sketch that, what that's going to look like. How'd you do? Okay. Now, as you took this journey, did you move it all southward? Was all of your motion southward? Nope. But was some of it? Yeah. How much was going purely southward? Well, about that much. See how we did that? This would be known as the y component. Huh. I'm going to need to figure out a number for that. Tell your neighbor how you might possibly calculate the value of the y component. So what are you going to use? Cosine. Cosine of 30 is equal to adjacent over hypotenuse. I find that to be, I think it was 104. Is that right? 103.9. So 104 meters. Now, is that going in the positive or negative y direction? Negative. How'd you know that? It's pointing down. Good with that? That would be the y component. Now, we can have a similar conversation about going eastward. Was I moving it all in the eastward direction? Yes. Was all of my motion eastward? Nope. Was some of it? Yep. How much? Well, about that much, which happens to be the same length of that side of the triangle. Without using this, but using 120 and 30, tell your neighbor what you would do to calculate that. You get 60. Is that going in the positive or negative y direction? Is that going in the positive or negative x direction? Positive. What would make it go negative? Which way would it be moving if it was in a negative x direction? Okay, so it's a positive 60 meters. That's the x component. Okay, you all heard of the word component before this class? Like components. Okay, it usually means like the parts or pieces of the whole. Okay, watch what happens when we find the resultant of the x and the y components. If we found the resultant of the purple and the green, that's going to give us our original vector. So these are the pieces that make up the whole. That's why we call it components. Sound good with that? Okay. Questions there? Okay. Seeing this as a multiple choice option, see if you can figure out the correct answer without even pulling out your calculator. Assume it's drawn to scale. Thumbs up when you have a guess. Talk to your neighbor and tell them why. Here's 34 degrees. Here's a y. Here's our x. Is everybody good with B? Bouncing buffaloes. Good? Okay. You got a worksheet due tomorrow over this stuff.